Hello sir, this is Bhaskarjit Sharma presenting you the statistics project, which was to explore the online shopping data and to do hypothesis testing on three factors, which are online resonance, human interface and privacy. So I have completed this project and I have created one markdown file. This is the markdown file, and after creating the markdown file I have clicked on HTML and I got an HTML page which later I have published on RPubs. So I am going to explain the project in the RPub itself, and in the meantime we'll go to the RStudio to do some coding demo. So let's begin. So let's first start with the data collection. So for this data collection we have used Google Form. Google Form is used as the mode of survey to collect customer data, and factors assessed by this dataset include different human emotions for after completing the online buying process. For example, does one feel satisfied after the buying online product, or does one feel furious after buying, does one feel uneasiness after buying the product, does one feel cheated. So there are 61 variables in our data set and 162 observation. Sorry for this typo here. And most of the variables in our data set are categorical in nature, and further if we classify those categorical, they are ordinal in nature. For example, how much they agree or disagree. This is the survey link. So if you go to the survey, these are the some set of questions which you will get through. Then I have also uploaded the dataset on my Google Drive. You can access the dataset from this link, and I have also created one code book. And code book is basically it is a document which provides the basic information about various variables present in the dataset, and it gives information about what the type of the data variable is or what value it can take. For example, all the column this question, they are categorical in nature, and if we further classify the categorical, they are ordinal in nature. So this kind of information is available within the code book. Now let's begin the conducting exploratory data analysis. So why do we conduct EDA? The main purpose of EDA is to maximize insight into the dataset, to uncover any underlying structure, or to extract important variables, to detect outliers and anomalies, to test underlying assumption, and etc. So basically we do EDA before we do any modeling process, to find out what pattern the data is having, or to mainly to get any insights the data might have. So then before doing EDA we have to load the dataset, and my dataset name is shopping.rdata. And after loading the dataset, I have used table.df function of deployer package. The use of table_df function is it converts data into table class, and tables are easier to examine than data frame, or displays only the data that fits on screen. So basically for use purpose we have used this table_df function. So you can see when I use the head function of this data frame shopping.table which I have assigned, then these are the results. You can see the timestamp, age, gender, marital status, and then education. So as I have used the command head, it will only show first 6 rows of the dataset, and remaining 60 more variable it will show only the factor variable names. So when in the raw data the variable names are not like this. I have changed the variable names which I have mentioned in the code book. So let me show you the code book as well. So this is the code book. So these are the new variable names which I have given, because earlier the variable names were very long, and it becomes very difficult to do analysis using those long names. So that is the reason why I have changed the column names of the dataset, and I make this code book so that one can use that particular column in his analysis. Now let's move back to the RPubs. So let me show you structure of the variables. For example, if I use the summary of the age variable of my data frame, then I can see there are 71 respondents who have the age between 20 to 25, 74 for 26 to 30 years, and 6 for less than 20 years, and for more than 30 years we have 11 respondents. So you can see a 0 respondent here, and we do not have any category here. So I will explain it what it is in coming few minutes. Similarly for unhappy as well, if we can see the summary, so it will show how many respondents agree that they feel unhappy after buying the products online. Okay, let's move on to data cleaning. So I have used the sum is.na and my data frame name shopping.table. It shows 0 as its result, and it is quite obvious because it confirms to a survey where we made all the questions compulsory to answer by the respondents. So we don't have any missing values, but there is one catch here. But to analyze the data set, we need to change the categorical variable codes, that is strongly disagree, disagree, neutral, agree and strongly agree, to the numerical codes 1, 2, 3, 4, 5 respectively. Now for example, as I have told you already that failed unhappy is a categorical variable. It can take all these strongly disagree, disagree, neutral, agree and strongly agree values. So let's see the structure of this variable. So we can see the structure of the variable has 6 levels, as opposed it should have 5 levels, but due to addition of this blank level it has moved up to 6 level, which is undesirable. So we have to remove this level from our data set. So to remove this data set, I have used for loop, because this is the common for all the columns, all the variables in our data set. So we have to remove this extra level codes from all our columns. So this code tells us for I in names shopping from 3rd column to 60th column, I am first dropping the levels. After dropping the level, I am assigning the shopping table all the columns, again the factor of that level, factor of that column. Now let's see the structure of that unhappy, failed unhappy column again. Now it is showing only 5 levels, that is from agree, disagree, neutral and strongly agree and strongly disagree. But our task has not still over yet, because the unwanted level is now removed from our data set, but still we have not assigned the correct number to each ordinal level of the variable. Correct number means, as you have mentioned in the project deliverable PPT, that strongly disagree should be assigned 1, disagree should be assigned 2, similarly strongly agree should be assigned 5. So we have I have used this function revalue of plyr package, and then I have passed this new level which I have assigned before running the loop, and then it is assigned to the shopping table, and then I use the command order. So it will then make the change the order of the levels from strongly disagree to disagree, neutral, agree and strongly agree. Now if I see the structure of that failed unhappy column, then it will show the 5 levels in the desired order that I have described in the new level. Okay, now my level is ordering of the level is done, but I have one more task to do. I have to replace those ordinal values by a number values. That means strongly disagree should have 1, disagree should have 2, neutral should have 3, agree should have 4 and strongly agree should have 5. So I will use the basic R command as dot numeric, and will pass all the variable and I'll assign to the same variable. Then it will convert the ordinal values to numbers. Let's say let's show you an example. So for example, head, if I do the head of the failed unhappy column, then I can see disagree, and if I then run the command head of the same column of the new table where I have made the changes. See, this conforms to the desired numerical value that was required. For example, disagree should have 2, we got 2. Neutral should have 3, we got 3. Agree should have 4, we got 4, and same thing goes on. Now, as we can see, numerical codes conform to ordinal levels. We are done with the data cleaning and manipulation step. Now let's come to the factor description to be considered for hypothesis testing. So you, in the project PPT, deliverable PPT, you have mentioned that we should consider 3 factors. Those are online dissonance, human interface, and privacy. So what I have done is, online dissonance is a score sum total of the variables: failed, unhappy, failed, made a mistake, failed, done a wastage, thought of corrective action, expectation not met, genuine discounts or not, return and exchange policy, and painful product placement, keeping promise, and no trust. So if we see above all the variables, we have collected responses on a scale of 1 to 5. That means strongly disagree to strongly agree. Means strongly disagree being 1 to strongly agree with score of 5. Therefore, as an organization, we'd like to have low online dissonance score, because if you see all the columns, they have a negative connotation. Failed, unhappy is a negative connotation. Failed, made a mistake is a negative statement or negative connotation. Failed, done a wastage has a negative connotation. Painful product replacement, no trust, they all have the negative connotation. So we'd like to suppose if someone asks me, do you have trust, then if my response is I disagree with this statement, that means it I have trust on the online shopping product. So we would like to have a low, the organizations would like that their customers should have low online dissonance score, as low score means online shoppers are highly satisfied with the online shopping experience. Therefore we need to they should come up with the policies, or come up with some products which make their respondents feel having a low dissonance score. So I will now add online dissonance score in my data frame by simply adding all those columns. And similarly for human interface is also a addition of the cash payment, then online payment or negotiation for better deal, missing personal touch, need of salesperson, smile of salesperson. So if you see in the code book what smile of salesperson means, smile of salesperson means after buying the product online, thus the respondent agrees with the smile on salesperson's face. If they disagree, they miss smile on the salesperson face. So if the respondent answers they disagree, then it means that they do not miss the smile on salesperson's face. So again, organizations would like to have low human interface score, because low human interface score means their customers are highly satisfied with the services, the salesperson give a smile back to them, they do not miss any personal touch. So they should get a low human interface score. Similarly for privacy, privacy is the simple addition of increase in spam mails, selling personal data, selling financial data, and decoding shopping pattern. Again, selling personal data means, does the respondent feel that their vendors sell their personal data to third party vendors? If some respondent disagree with this statement, that means they do not feel that their personal data are being sold to third party vendors. So again, in this case as well, the organizations would like to have low privacy score. So in all these factors, privacy, human interface, or the online dissonance, a low score is desirable while a high score is not desirable. Okay, now I have also added the privacy score, and then human interface score, and then online dissonance score to my data frame. So this after adding this is how the data looks like. And then now let's come to hypothesis testing based on gender. But before doing the hypothesis testing, let me do one data analysis, exploratory data analysis, just to show how the values varies for different scores. So I have used a mailed function of reshape package. So just my intention was to show you all the variable score, online dissonance score, human interface score, and the privacy score all at the same graph, so that we can make comparison between these three scores at the same time. So that is why I use this mailed function, and by id is my gender, and the measure variables are online dissonance score, human interface score, and then privacy score. So I have kept the data in the shopping table gender, and then I use ggplot of the ggplot2 package, and I have plot the box plot, and I have differentiated those product by gender, male and female. So as you can see, online dissonance score is very high, and then human interface score has medium values, and privacy score has low values. As I have already explained, from an organization's point of view, all those three scores, they will prefer low scores basically. So this online dissonance score is very high, so we organizations would not like to have high score, so they should come up with policies or come up with some promotions or products, so they can reduce this score among the customers or among the this respondents. And if you see privacy score, this is very low, so their organizations would be happy to have very low privacy scores. Now let's go to the hypothesis testing. But before testing, you have asked to take a sample of size 80. So I have created one variable n, and then I have taken a sample of size 80 by using this function sample n of deployer package. Now let me I have done the hypothesis testing for online dissonance score based on gender. So I have used the inference function. Inference function is available with the statsr package. My y variable is online dissonance score, and I am doing this hypothesis testing based on gender, and the data is the sample of 80 observations, and then statistic is mean. So there are different statistic which we can provide: mean, median, and mode. But we need to do this by mean only. And then type is hypothesis. HT means hypothesis, and then null is equal to 0 means the null value, null hypothesis value, which is basically the 0 as always. And alternative is two-sided. Generally for alternative we have two parameter, one is two-sided and another one is greater, but because we are doing a two-side comparing, means it depends on the alternative hypothesis. So here our alternative hypothesis is mu of female is not equal to mu of male, so we have to do a two-sided test. So that is why the alternative is two-sided, and the method we have used is theoretical. In method also we have two different parameters which we can pass. One is theoretical and another one is simulation based. So the difference between theoretical and simulation is, for theoretical it uses the central limit theorem method, and for simulation based way, if we pass simulation, then it do the hypothesis testing based on bootstrapping. So we will be doing central limit theorem, so that is why I have used the method theoretical. Now after running this command, I got this following result. The response variable is numerical, explanatory variable is categorical, which is gender, two labels means male and female. So here's the test statistic for female, and following below one is the test statistic for male, and here is my null hypothesis, mu female is equal to mu male. Here is my alternate hypothesis, mu female is not equal to mu male. And as you can see, the t statistic is less, but the p value is very high. So and one more thing I forgot to tell you, the inference function, by default it uses confidence interval of 95%. So if you want to change the confidence level by let's say 99.7 or 0.90, then you have to add one parameter, conf underscore level is equal to 0.90. Okay, So this is the graph, this is the sample distribution of female, this is the sample distribution of male, and this is the null distribution. As I have already told you, p value is very high, it is almost 92%. So there is, it almost spreads over all over the normal distribution. Now let's move to hypothesis testing for human interface score based on gender. The same function as earlier, but only changes this. Earlier I used online dissonance score, now I am using human interface score. Same, almost similar result as earlier, except this p value. Now p value is a little bit less than earlier, which is 27%, but it is still greater than, because our confidence interval was 95%, so it is 27%, which means it is we are failing to reject the null hypothesis. Similarly, for the privacy score based on gender, the same function as earlier, only change in the y, that is privacy score. And here as well, the p value is 0.716, that is 71%. So again, we are failing to reject a null hypothesis here again. So it means that data shows confidence that mu of female is equal to mu of male on an average. Now we come to hypothesis testing based on marital status. Before doing the hypothesis testing, let me show you the data again, how the data varies for different scores. So I have used again this male function, but before, one more thing that I would like to mention here. As you have earlier told in the project deliverables PPT, we have to remove single again from the marital status variable. So I have filtered that out. I am not including the single again value for the marital status, and I have saved this observation in a different data frame called removing single again, and by using this data frame I am doing the following analysis. So here again, if you see the box plots across various different scores, online dissonance score and human interface score, privacy score, again we see the same pattern. Online dissonance scores is very high, organizations would like to have less online dissonance score, and privacy score is low, so there is no such changes required for this privacy score. This is very low, and organizations would like to have low privacy score. Moving on, as you can see, as I have told you, we have removed the single again observation. So single again observation is now 0, but to do the two hypothesis testing, we have to remove this level as well, single again level as well. So I have used this drop level function to drop all the levels, and then I have used order factor function. So what the drop level will do, it will drop those levels which have 0 observations. So using drop level, it will drop the single again function, and from factor again we will assign it to the marital status, then it will have married and single. It will remove the single again. As you can see here, after running this command summary of marital status, we get only married and single. Now taking the sample again, I have taken the sample again because if the earlier sample, had I been used earlier sample, then there was a chance that the single again variable might come into the sample. As you have told that we have to exclude the single again value from our analysis, so I have used a new sample again, which thereby reducing the chance of taking single again value in our analysis. Now I am doing the hypothesis testing for online dissonance score based on marital status. Same function as earlier, inference, only change now is on the X factor. Earlier we were using gender, now we are using marital status. Now if you see the observation, the p value is 0.9325, which is very high, or 93%. So we are again failing to reject our null hypothesis. So data shows very confidence that mu of married is equal to mu of single on an average. Moving on, now we are testing the human interface score based on marital status, same function as earlier. Now if you see the p value, which is 0.465, that is 46.5. Again, is very high. We cannot reject the null hypothesis. We are failed to reject null hypothesis. It means mu of merit is mu of single for human interface score on an average. And then testing privacy score based on marital status, the p value is 66.15, that is 66%. Again, we are failing to reject our null hypothesis that mu of merit for privacy score is equal to mu of single for privacy score on an average. Now comes the third factor, based on education, hypothesis testing based on education. But before doing hypothesis testing, I just wanted to show you how the data varies for different scores. Here's the box plot again. For there are 5 levels for education: graduate, others, postgraduate, professional, and undergraduate. So again, the same pattern we can see. For online dissonance score, we have very high score. For human interface, we have moderate score, and for privacy, we have low score. And as I have repeatedly told you that low score is preferable. So again, we try to organization should try to reduce this online dissonance score and human interface score, keeping privacy score as is because it already has a low score. Now the method I have used for this hypothesis testing based on education is I have used ANOVA testing, because earlier I was using two tests which was only useful for comparing two means only. So in cases where there are many more than two levels, so two-tailed test fails to do the analysis. So you can see education have 5 levels: graduate, others, postgraduate, professional, undergraduate. So by ANOVA testing we can do the analysis in one go at a time. So let me state you the null hypothesis for ANOVA testing. For ANOVA testing, the null hypothesis is mu of graduate is equal to mu of undergraduate is equal to mu of postgraduate is equal to mu of professional is equal to mu of other. And its null hypothesis is at least one of the level, that is graduate, undergraduate, postgraduate, professional or other, is not equal to each other. We don't know which one it is, but we only care about at least one of the level should not be equal to each other. That is our alternate hypothesis. So I have used the same function inference. The only change now is I have changed the alternative to greater. Earlier I was using alternative as two-sided. Now I am using alternative as greater, because in ANOVA testing there is the distribution we generally get is called F distribution, and we do not get value less than 0. The output for this ANOVA testing is the p value that we are getting is 0.435, so which is again greater than 5%. So we are failing to reject our null we are failing to reject our null hypothesis. It means that the mu of online dissonance score for all levels of the education are equal on an average. Next, moving on. For interface, human interface score, again we are using the same function. Let me check the p value here. The p value here is 0.2225, that is 22%. So again more than 5%. So we again fail to reject our null hypothesis. So we can say that the data shows convincing evidence that on an average the mean of human interface score for across all the level of education are equal. Lastly, the privacy score based on education, same function, and the response here p value is 8.8258, 82%. So we can say on an average we are failing to reject our null hypothesis again. So we can say that the data shows evidence that on an average the mu of privacy score for across all the levels of variable education are same. That's it. Hope you enjoyed my presentation. Thank you so much.